a lot of people are like, oh, what's the magic? It's no magic. It's just what did every other tech platform do when they needed to become high performance and scale? They built a purpose-built, custom dedicated network underneath.
What's up, guys? This is Boccaccio, the bad host.
And the better host, Danny.
Today we have a very, very important announcement for you. We are hosting Permissionless in Brooklyn. What dates?
It's going to be in June 24th through the 26th.
Very good. You can use code 0x10 to buy your tickets. We're going to do lots and lots of stuff. Dinners.
Games. You'll get to meet the whole crew, the OX Research crew, hopefully a bunch of the Blockworks Research and other Blockworks crew, and maybe a dunk tank.
We're going to have fun. Whatever we can smooch off of Yano and Mippo, we're going to do it. So if you are a 0x Research listener, make sure to use code 0x10 to buy your tickets. Danny, any parting words?
And we'll see you there.
Nothing said on 0x Research is a recommendation to buy or sell securities or tokens. This podcast is for informational purposes only, and any views expressed by anyone on the show are solely our opinions, not financial advice. Boccaccio, Ryan, and our guests may hold positions in the companies, funds, or projects discussed. What's up, guys? Welcome back to another episode of 0x Research. Today, I'm joined by Austin and Mateo from DoubleZero. Thanks for coming on, guys.
Thanks. Great to be here.
Thanks for having us.
Perfect. Before we get started and actually dive into DoubleZero, I kind of want to get a bit of background on both of you and what you guys do over at DoubleZero, if that works.
Yeah,
sure.
Go ahead.
All right. So I am one of the three co-founders here at DoubleZero. I am the co-founder that is attached to the foundation side of the project. So I also serve as the president of the foundation here. And prior to joining DoubleZero and co-founding this thing, I spent the last 4 years at Solana Labs and then the Solana Foundation.
And I'm Mateo Ward. I'm the co-founder of Malbec Labs. And Malbec Labs is a core contributor to the DoubleZero protocol and network. And we primarily do protocol and network engineering.
Perfect. Fantastic. And another introductory question. What is exactly DoubleZero and how is it beneficial to the general crypto landscape?
Go for it, Mateo.
Well, I guess people on the internet are tired of hearing Austin say it, so we'll try to give it a little different spin this time. DoubleZero is a alternate internet, a purpose-built internet for distributed systems. And what that means is that it's not a general purpose network. And you might find it funny to hear someone describing a project in the negative, but it's very, very important to understand the difference between general purpose and purpose built. And so basically what we do is we say, what does a time-sensitive distributed global system need in order to operate at high performance? And we build a purposeful network that is exactly focused on delivering that performance. So that's what DoubleZero is high level. We'll dive into more of the details of how it works, but basically it's a really fast highway for cars to drive on.
Perfect. And why do we need it? In the sense that I read over some of the tweets that Austin put out, as well as your white paper, and one thing you guys mentioned is that compute is not the bottleneck anymore, and that the bottleneck is bandwidth limitations. That's the word. What does that mean more simply? And then maybe you can dive into why DoubleZero is necessary.
I think I'll start with the high level, and then I always love to hear Austin talking about why the bottleneck exists in blockchain specifically. But if you look at the high level, every single tech segment and industry has gone through an evolution where they start out at a hobbyist level, running on whatever internet they can get their hands on, whether it be a LAN party for gamers, or whether it be the public internet for networks like YouTube when they started out, or Netflix when they started out. And I don't know if you remember, if you ever watched Netflix or YouTube pre-private network, but around 2006, Google deployed their global private network, and YouTube started using that. And all of a sudden, you stopped getting buffering and delays and bad user experiences. The same thing has happened in cloud networking. AWS, Google Cloud, all the big providers have these huge private networks, purpose-built networks based on submarine fiber, terrestrial fiber, all linked together. And so, basically the time has come where blockchain needs to do the same as every other tech industry. So a lot of people are like, oh, what's the magic? It's no magic. It's just, what did every other tech platform do when they needed to become high performance and scale? They built a purpose-built, custom, dedicated network underneath. And we got to blockchain and we said, oh, blockchain has some specific issues. And that's where Austin can kind of help us get that insight.
Perfect. Austin, do you have anything you want to add?
Yeah, so I mean, this is kind of one of those funny things where when people talk about the problems in blockchain today, they're really focused a lot on compute. And one of the questions you should always ask yourself is why, right? Why is compute the thing that gets so much attention? And because it's kind of the easiest thing to solve, right? People solve the problem that they know how to solve and the problem that is immediately in front of their face. And so a good question to ask yourself is, why are testnet numbers always so much higher than mainnet numbers, right? And there's two reasons for this. One is mainnet load is different than testnet load. That's very kind of important to remember. The other, though, is that testnets are usually small deployments in some like small data centers, or they're running in much more controlled environments. And the thing that we've seen from like pretty much, I would say, mid 2021 onwards are that validator clients now, the software that actually runs these things, can do very high performance systems. Now, if you go back to 2018 and you ran Geth locally, you weren't getting over 200 to 400 transactions per second on the EVM. That's different nowadays. You look at something like Solana, and you can do 1 million transactions per second on the Firedancer client. You can do close to that on the Agave client as well. And you can actually look at how does that actually scale out when you're looking at a testnet? And one of the pieces you run into is, if you were at Breakpoint last year, you saw a demo of 1 million transactions per second running on, I think it was 6 nodes on 4 continents. And that was actually running on the DoubleZero network. If you'd run that demo on the public internet, you would not have gotten 1 million transactions per second. And so really we've reached this point where for years it was the software that was holding blockchains back. And it's no longer the software. And so like our goal at DoubleZero is to like make it the fault of the software people again.
Very good. One thing I want to ask about is, we typically say that consensus is an issue. Coming to consensus is an issue because let's say New York and Japan need to communicate, like validators in New York and validators in Japan. Is this what DoubleZero would help out with? That would be much, much quicker because it wouldn't get routed through some random.
There's like a bunch of different ways to think about this. And I think probably the easiest to start out with, and I'll have Mateo do the harder one, is like the point-to-point communications, right? And so if I am trying to talk to a computer in Singapore from New York, traffic will bounce all around the United States, before it actually heads in the right direction and eventually gets over to Singapore. And there's a bunch of reasons for this. The main is business use cases, which is that like the way that these business models are constructed over the last 30 years is not to incentivize performance. It's to incentivize basically least cost routing and getting data off your network as quickly as possible. And so even just on the one-to-one example of I'm just trying to send a packet from New York to Singapore, it's not going to take an efficient route because the business models basically don't support that today. Like, you'd be surprised to learn this, but there's actually no way to pay for packet prioritization on the public internet today. Like, I can't just say, oh, I'm willing to spend a bit more money, like a Jito tip or something like that, and get this thing processed more quickly. Like, that doesn't exist. And then there's a whole other problem, which, Mateo can talk about, of the one-to-many communication style of blockchain, which the internet just wasn't built for.
Yeah, I mean, just to add on to that, why does the traffic bounce around all over the US, all over the world? It's related to the way internet routes traffic. You can see on my shirt here, this is the current ASN number, autonomous system number, that we're using on testnet. And it's one ASN for the whole world. That sounds simple, but that's a huge statement, because on the internet, you've got dozens and hundreds of different ASN numbers. Each one is a different network, and they have to pass traffic between them. And they use a protocol called Border Gateway Protocol, BGP, to do that. And as Austin said, the BGP attributes that route that traffic have many different factors. It could even be geopolitical, be like, don't cross over this country. It could be, use this border router only in Dallas. When the traffic needs to go to Seattle, it's going to route through Dallas. Think about it as an airline hub system, right? You know, if you're going to have to take a connection on a coast-to-coast flight, it's never going to be the direct straight line. And so you're always going to go through a hub. It's the exact same thing here. And what the magic of what DoubleZero does is it routes the entire world on a single ASN number, which means that every single packet goes straight to the location that it's going to. And there's peering between every node on the DoubleZero network and every other node on the DoubleZero network. And that is not the case in the internet. There's peering at the edge, there's peering at these specific points. Carriers fight with each other, and then they de-peer, and then you can't ever deliver traffic directly to that city. There's so many different things that happen, and we've solved that by having this single mesh of peered routers all around the world under a single ASN number. And we've done it in a decentralized fashion with multiple network providers, which is the key, because any other network that's like this one is a centralized, privately owned network. And we've brought that into the public domain. We've made it decentralized, and we've made a whole community of contributors that make up that unified network.
Yeah, and this really is like where you need tokens, right? Like a lot, like we get asked every once in a while, like, oh, like, do you really need tokens? Couldn't you just build this as like an equity company? And the answer is like, no, because we need the ability for everyone in the link of the chain, for lack of a better term, every single network provider that you pass through to get from New York to Singapore in the most efficient route possible to get paid. And that's like, sounds like such a basic insight, but like that is not how the internet works today for the most part. And so being able to have these things, whereas Mateo was talking about, the incentive of every provider is to provide as most useful service as possible because they'll earn the most rewards, right? The links that give the biggest advantage over the public internet and reach the most amount of stake or validators or RPCs are the ones that are rewarded most on the DoubleZero network. And so the incentive for everyone is, how can I make my links as performant as possible and as useful as possible? Which, like, again, sounds like the way the internet should work, but it's not actually the way the internet works. And this is really only possible with tokens.
That makes sense. I'm glad you guys brought up both tokens and contributors, because I want to ask about this. Mateo, maybe first to you, because you brought up the contributor side. Who are the different stakeholders for DoubleZero? Who are the involved parties that you guys have to deal with and that you guys have to coordinate with?
Yeah, let's start up high level. It's anybody that has network that's high performance, low latency, low jitter, and wants to contribute it to a global new version of the internet. And when you look at that high level, you're like, wow, this is a huge market opportunity. When Starlink was launching their project, they took the TAM to be $1 trillion, which is the annual amount of revenue on the internet. $1 trillion. They wanted to get 3 to 5% of that, 30 to 50 billion. And today they're at 11 billion. They're doing fine. And so there is a massive global market for connectivity, and there's lots of people that own capacity. And so a new use case for applying that to a monetizable project is wonderful for all of these people that own networks. And so really the addressable contributor base is anyone who owns and operates a high performance network that wants to be part of a new internet. Zooming in and making that into a timeline, you get different phases. You get the early adopters, and those early adopters are the ones who probably understand blockchain. They understand what a utility token is and the value that might come out of that. They have underutilized capacity, so they've got a global network that's being used for another use case in-house, and they have a slice of that they could contribute. And they're risk takers and people that want to believe in something new, sort of bleeding edge tech adopters. And this is a really fun group. These are the ones that have initially committed to the network. You've seen them in some of our press releases. You've got companies like Jump Crypto. You've got other VCs that have contributed. We've got Rockaway X, we've got Distributed Global. We've got a number of people that said, I'm going to make a bet on this because I think it's the future. And then you've got phase 2, which are the wait and see ones. We're already starting to get some of those where they say, oh, wow, I see this actually works. There is value here. I can create a business case. I can do an ROI analysis, and I'm going to go in that. And that includes also carriers and other enterprises. So there's large enterprises that may not be high frequency trading firms or others that just have a network and want to contribute it. Retail companies and others, they all have private custom built networks because they all need to move data around very quickly. And then you've got phase 3, which is equally interesting, which is entrepreneurs, capitalists, and all kinds of people that are like, wow, I've got this ecosystem now that's a tokenized version of telecom CapEx and of shared networks. And I can pull together the pieces myself. I can go out and find someone who's going to provide me with data center space. I can find someone who's going to lease hardware. I can find someone who's going to lease me connectivity. I can pull it all together and contribute it to the DoubleZero network and earn tokens on that. And that's really the end vision that this really becomes viral, because after the institutionals, if you get this thriving ecosystem of entrepreneurs contributing assets to the network, it really scales quickly.
That makes sense. So the first, I guess, users that will be onboarded, apart from those who have already committed, are mainly people who already have these resources set up and that are just willing to give, instead of people. This isn't something that I could do, for example, until later on when I can tell that it's going to be very valuable.
Yeah, I mean, this is, you can think about this as like a professionalization of the role of infrastructure in blockchain, right? So you start off with like a Bitcoin miner that you can run on a Raspberry Pi and you can run on a generic computer. And nowadays, like, you really can't mine Bitcoin unless you're investing in ASICs and you're in an area with cheap energy and you're putting significant, CapEx and OpEx into that operation. You had, Ethereum where, like, sure, in theory, you can validate on a Raspberry Pi, but you can't really, like, if you want a full node, it does still take a reasonable real computer. But that network is quite slow. And you look at anything else, whether it's Sui or Aptos or Solana or any of these like L2 sequencers out there, they're very heavy machines. They're basically professional operations at this point. And so individuals and small companies can certainly run infrastructure for all of these networks, including DoubleZero, but it's not really the type of thing that you're expecting like an average home user to do, because quite frankly, these economies have just gotten so profitable and so performant that this is like a mark of success, that like this is not a hobby for anyone anymore. This is like a full-time job to be an infrastructure provider for a modern blockchain. And so DoubleZero sort of asks the same out of folks. We do have, small firms that are providing capacity to DoubleZero. We have two firms that have never done this before, right? Rockaway X never had any private fiber. Distributed Global never had any private fiber as well, and they're contributing, to the DoubleZero network at this point. So it's not like you have to be like a Jump Trading or a Galaxy or a TerraSwitch to be able to contribute capacity, but you do need to be putting in real resources to this, because this is mission critical infrastructure for networks that build on top of it.
Yeah, as it should be. I'm not a huge fan of the local stakers, which I assume will find support here. Austin, you mentioned, I'm happy you brought up tokenomics, because that means I can ask about tokenomics. We don't have to get into too much detail. You can always say you don't want to talk about, or it's not decided
It's all
yet,
public.
which is very acceptable. That's true. I saw that. Typically, I guess DePIN style projects where there's incentives for network operators, they face an issue where if you pay out in the native token, sometimes it can go down in value, as we see within all currencies. And that can be an issue for, I guess, operators. Is this something that you guys thought of where you wanted to maybe go with USDC instead? Am I doing something
That's
wrong?
not the problem with DePIN. The problem with DePIN is not that they pay out in the local currency. The problem with DePIN is there's usually no demand side. There's only supply side, right? In any market where all you have is supply side, you're going to get a downward looking graph, right? And so, one of the things that I think is really important with DoubleZero, there's kind of a few different things we've done. For example, there's no base level contribution reward. Just for running a piece of fiber, you by default get nothing. If that piece of fiber is not useful, if it's not providing connectivity into areas where people run Solana validators or RPCs or any other type of infrastructure on the network, you're not going to get rewarded just for passively having fiber. Most DePIN networks, they give you sort of this passive coverage or capacity subsidy, which encourages farming. And it is extremely hard to farm DoubleZero tokens without providing actual value to the network, which at that point is not called farming, it's just called being a good network contributor, right? And so a lot of this is just like good economic and system design. A lot of this credit goes to Nihar, who is our chief economist over at the foundation and has done a ton of work on this type of thing. But the other piece too is like we are charging validators to use DoubleZero. We're charging RPCs to use DoubleZero. And so the network, once it launches in mainnet, assuming people adopt it, will have revenue inflows to it. And so, the way that this works is it's not like we're just minting a bunch of tokens every month to give out to network contributors, right? This isn't a network that operates that way. Validators and RPCs pay to use the DoubleZero network. Those rewards are, if they're paid in native Sol or if they're paid in DoubleZero, either way, they end up in this reward pool. They're all converted into DoubleZero tokens. A portion of those are burned, and then a portion of those are distributed out to the network contributors. So it's not like we have, like a 10% inflation rate and we're just like printing a bunch of new tokens for network contributors. It is revenue derived. And we think this is like a good, solid framework to build this stuff out. We do have a property right now where a number of our contributors are also investors in the project. And so, there is obviously with any DePIN network, there is a cold start problem. And that's sort of the way we're working on a bunch of that cold start problem. But, these are the type of systems where like if we're not doing our job and the network's not generating revenue, like that's on us. And that means we haven't done this thing correctly yet. And so I think you see this very Web 2 model in a lot of like networks nowadays of grow the thing and like, we'll figure out how to make it valuable in the future. And that works if it's useful, right? Like I think like the thesis for Solana, and like this was always Toli's thing when I would talk to him about this back in like 2020 and 21, was like, or end of 20 and mostly 21, was like, we just need to make Solana useful and then we'll figure out how to make it valuable. And the problem with most DePIN networks is they're not useful. They're theoretically useful, but their practical use is very low. You can say this about not just DePIN networks, but a lot of L2s fall into the same category. A lot of new L1s fall into this category. As long as DoubleZero is useful, and so that means we have validators and RPCs choosing to connect to it, we have networks building on top of it, and we're able to provide increased bandwidth and reduced latency. The monetization side of things, like I hate to say we'll figure it out because there's actually a lot of like stuff in the white paper and on the economics.doublezero.xyz about like how these things really will work. But like in some ways, like Solana base fees on Solana were extremely low, and they still are extremely low. Prioritization fees have addressed that. A bunch of MEV fees have addressed that. There's lots of different systems once you have a useful network where you can figure out what monetization of that really looks like. Our focus is building something that is going to accelerate crypto by 10 years. And if you can run Solana at 50,000 transactions per second by the end of the year, and then you can run it at 500,000 transactions per second by the end of next year, like, at that point, the economics of the network kind of solve themselves.
That makes sense. One thing I want to ask about that you mentioned is that validators and RPCs and whoever uses the network will pay you, which makes sense. I remember there being a proposal about the DoubleZero take rate, and it was 5%. Another thing is Jito, I guess, started off, they also had a cold start problem. Like you said, most of these networks have cold start problems. And they had very low take rate. I think they ran at a loss for the first until they were adopted. Is that something you guys are also going to do? I assume the 5% is not the initial rate. Is that correct?
It's a phase in, and we have to sort of earn that from, the network, I would say. Like if DoubleZero makes, let's just fast forward to a world where DoubleZero makes validators twice as profitable. I don't think there's going to be a hard time asking them for 5%. In a world where DoubleZero has not shown itself being able to make these validators like twice as profitable yet. Sure, maybe that's a big ask, right? But part of this too is I like, from a deep philosophical standpoint, if you work at a protocol and you're listening to this podcast, turn the fee switch on. Everything before the fee switch is just LARPing product market fit, right? It's so easy to get people to do stuff on your network when they're not actually having to pay to use it. And so it's the same. To me, it feels very spiritually similar to like low float, high FTV tokens, or tokens that launch before a network launches. Like, it's not really serious until you're asking people to pay for it. If you're just giving away the service, like, you haven't found PMF. You've found, if you open up an ATM on the side of a street corner, you're going to get a big line. And so this is part of why I feel very strongly that we are going to start with some fee on the network. It's not going to be 5% of inflation, but the 5% of block rewards seems like a very good place to start for this type of thing, because at the end of the day, like, we are providing a service above and beyond what the public internet can provide, and that is, we believe, worth paying for. And if other people don't find it worth paying for, that doesn't mean it's not worth paying for. Right? That means that we haven't made the use case correctly, or the utility is not quite there. But fundamentally, this cannot exist as a free network.
That makes sense.
Physical infrastructure is expensive.
This is something that I feel really strongly about, and I've been talking to some friendly validators and debating it. And they ask, well, what about the fees? And I say, I don't know. You tell me. Isn't this your network? This is not my network. We built this network for blockchain. This is a blockchain native network, and this is the most efficient way to mine bandwidth or extract bandwidth out of these networks that I have ever seen in 30 years of networking. And so basically what we're saying is, we're going to help you with this protocol extract bandwidth out of these networks at the most efficient way possible, with marginal cost, with no big CapEx step ups like every other person who builds one of these networks needs to pay. And we're going to charge a nominal fee that's going to be funneled back to these network contributors that are working together to provide you this shared infrastructure. And it's going to be a super efficient model that we're all going to participate in, and that you're going to have a voice in. And this is the wonder of blockchain. We're all going to be moving this forward together. So basically, it's all up to us, the validators, the network contributors, the people working on the protocol, to make this economic model the most efficient possible. And if we can't do it, then nobody can, because this is a really great group of validators we're working with. The network contributors are brilliant. They've built some of the best and fastest networks in the world. And so I think we're really well positioned to have a great economic model as we move it forward.
Perfect. What does the performance improvement look like compared to, like, if I'm a Solana validator and I'm using DoubleZero versus I'm a Solana validator who's not using DoubleZero? What am I saving on costs? Is the TPS much higher? What does that look like exactly?
There's a technical way to understand this, which I'd like to go into first, and then maybe Austin can talk a little bit about what we expect at the protocol level. But first of all, to answer your question, we expect a significant improvement in aggregate performance. Significant has multiple metrics. There's how much CPU processor time do you free up? There's how many more transactions can you process in a block, et cetera, et cetera. But what I want to go to is, how does this system work from the ground up? From an architecture, from a tech stack perspective, you take the hardware that the fastest and best and most efficient networks in the world use today. They're very advanced low latency switches, and then you connect them together with fiber on the fastest routes that are available with low jitter, because there's crappy fiber routes as well that have high jitter. But we focus on the high quality fiber routes that are wavelength based, preferably. And so you've got this super ultra fast point-to-point mesh all around the world. And then on top of that, we build the filtration stack with FPGAs. We're implementing AMD V80 FPGA cards that are basically a bump in the wire, and that can efficiently remove traffic that is not meant for processing, right? It's basically like a green light, red light bump in the wire. Traffic goes over it. If the packet's not signed properly, if the packet's a duplicate, it gets discarded, and the proper packets are forwarded on. And so that's another area where there's a huge efficiency that's going to be created for the validators, because they're not going to have to process that traffic. And then we go to how we route that traffic, which again is way more efficient. As we said, we are using a full mesh, point-to-point, fully peered global backbone that's going to go very efficiently. So when you combine that all together, we know that there's an exponential increase in aggregate performance. We know that not because of our testing, we know that because every other industry that has implemented this has experienced an exponential increase in performance. And we've worked in those industries. So bringing that here, we know it's going to happen. What we don't know yet is the exact percentages. We can guess. We think there's going to be probably 70% reduction in traffic that has to be processed. The garbage traffic has to be processed by validators, but we're not sure. We have to wait and see. We expect there to be 30 to 200% latency reductions at an aggregate level. The reason the range is so big is because the internet has all kinds of different ranges of latency and huge amounts of jitter. And so when you put that all together, we're extremely confident that what it's going to be. And we invite the whole community to watch publicly as we go through the testnet into mainnet and publish these statistics, because these are statistics that we're going to publicly expose. We're already seeing some of that. We can probably talk about it later, but today is a new day for DoubleZero. We just finished a testnet upgrade to what we call IBRL mode. So validators are reconnecting to the network in the new version of it using a single IP address. And we're getting a lot of stats and graphics and traffic analysis that we're going to be able to process and publish over the coming weeks and months to show that aggregate improvement.
Perfect. Before we talk about it on the protocol side, I want to understand what garbage is in that sense, the things that you weed out with the AMDs. What does that look like that doesn't go to the validator? Because in my mind, it's not signed correctly. What does that exactly mean?
Yeah, totally. So you got to remember, this is all public key, private key cryptography. That is what all of these blockchains are built on. So if the signatures don't match, right, if there's a mismatch, it fails signature verification. And so stuff that fails signature verification are bad transactions, right? So like if I sort of pretend I'm signing for you on your wallet, I can't unless I have your private key. But a lot of people send those transactions through, right? And it's usually not because they're actually hoping that they gets included in the block. It's that it actually gums up the works on validators, right? And so you can think about this from the perspective of like, there's a few ways to make sure your transaction lands. You pay a high fee, right? You like use Jito or something like that, or you just make it so no one else can send transactions. And when we go back to periods of time where Solana was suffering from congestion, or the Shanghai attacks that Ethereum suffered back in 2019, was that? I can't remember exactly. Those are examples of basically economic denial of services. And so if something fails signature verification, it is ineligible to be included in the block. It simply has no chance of ever, or it should have no chance of ever making it in, because it'll be rejected by the rest of the network. And so we can do things like perform signature verification in hardware on FPGAs at 100 gigabits per second. And what that basically frees up is a ton of a validator's resources to not have to worry about doing signature verification on everything that comes in. Now, they're going to do redundant signature verification on what they choose to include, most likely, but they stop having to sort through this giant pile of invalid signatures to just find the ones that are valid signatures they would want to include. The other thing that we can also do is packet deduplication. And so, sometimes what happens is someone sends 100 million copies of the exact same packet to the Solana network, again, to try and overwhelm the resources of the validators. It sorts through these things and says, oh, I've seen this before, I don't need this. Oh, I've seen this before, I don't need this. That takes a lot of time, right? Again, we can do this in FPGA at 100 gigabits per second. And doing it there, it basically means that what validators are getting at the end of the day is a clean stream of transactions. Doesn't mean all the transactions are high value. It doesn't mean they're all quote unquote good transactions. They could be a bunch of stuff that actually will fail in execution, because remember, a failed transaction on Solana doesn't mean the transaction didn't execute. It just executed with no state change. So for example, I try and buy Sol at a price that is the market has now moved from. Well, that transaction, it's formed correctly, but it's going to fail because no one will sell me Sol at $20, right? For example. And so this is basically the way that like DoubleZero can help make these systems more performant, is we can act as this filtration layer to throw out all of the stuff that has no chance of ever making it into a block to begin with. Now we look forward into the future, and like there might be other things we can do in FPGAs as well. What if we are now able to say, okay, well, what if there's a CU to fee ratio above a certain amount? Well, we're going to flag those as potentially high value transactions. And then a validator, again, validators are dictators, right? They have full domain over whatever they're building for that block. It has to be voted on by the rest of the network, but they could include whatever types of transactions they want, or build even an empty block if they want to. And so we can, over the long term, start providing a bunch of additional value add data to validators about the incoming stream of transactions that they're getting, to both filter out garbage and to help them make better decisions about profitability.
That makes sense. Would you would it be possible to add a bidding mechanism to something like that, where if there is high valuable transactions that you can ask people to bid for them, or is that something that doesn't make sense?
If FPGAs don't really operate statefully in that way, so these are sort of like, you can think about this as like there's a ton of stuff a computer does that's like sticking something aside to look at it later, right? And this is like an auction system. It's like, oh, we have a slot here, we're gonna take bids or whatever. Like these operate more almost like filters. You can sort of think about them, that you can do a ton with an FPGA, but the way that we have these things built is it's much more of like a pass, don't pass, or pass with some modifications attached to it, because the goal of the FPGAs, and the reason we're using FPGAs, is they're incredibly fast from a latency perspective for the type of operations we're trying to perform. So this doesn't add, like if you're adding an auction in line, suddenly an auction takes time to run. So that adds latency. And our whole thing is increase bandwidth, reduce latency. And so someone could, like, what we would basically say if someone wants to do that is, that's Jito, or you should build a Jito competitor on top of the DoubleZero network, but you're going to need x86 machines to do all the normal things you'd want, compute done on a network for. It's not really something that you'd handle through the FPGAs.
That makes sense. And one thing you mentioned is that you guys process that at 100 gigabytes per second. Can you put that in comparison to what how much space is this freeing up for validators?
Yeah, so most validators today are operating with somewhere between a 1 and a 10 gigabit internet connection. And so this is anywhere between 10 to 100 times the capacity that they currently do. The largest DDoS attack that Solana has ever sort of suffered that we have metrics on was 80 gigabits per second coming into one data center. So this, I think this is more than we've ever seen the Solana network be attacked for previously, which is pretty awesome. Mateo, do you remember how many actually transactions per second 100 gigabits is that we can SIG verify?
No, I'm not sure in the Solana protocol, but
yeah.
What I wanted to add to that is that with 10 to 20 lines of code, you can define what you want to do with a packet in this wonderful software that has been built. Jump Crypto did a lot of the development on that. And so you can go in there and say, very simple code, I want you to do this with the packet. And you can adapt it to other protocols, other blockchains, other use cases, whatever. It's sitting there as a filtration layer in the network, and it's extremely powerful. But there's definitely a huge capacity to do transactions in there, and they'll scale. These are not going to stay at 100. Technology scales, and they'll scale up, and will be able to compete very effectively with centralized systems like Visa or credit card processing, or NASDAQ, or anything that processes millions of transactions.
Perfect. One thing you mentioned is that it can be customized for other chains. You guys in your white paper talk about being able to use this for other L1s, RPCs, other L2s. What does that look like I guess, or do you have anything on the roadmap that you're like, we want to focus on this? Is this for any chain, or are you going to mainly focus on Solana for the next year and a half?
I mean, Solana is the place where there's the highest product market fit at the moment because it is built in such a way that it needs like the validator client is high capacity. The it's a lot of validators, right? It's the largest validator set for a high performance network in the world, with about 1,300 validators at the moment, and then probably another 700 RPCs. So 2,000 different nodes around the world. There's actually like a ton of use cases there, and like the more nodes you have, the more you need DoubleZero. And we haven't even talked about Multicast yet. That we'll get into that in a minute. That's a whole other use for this. But Solana also has a ton of activity and has very competitive activity. And so networks where there's no competition, the filtration services aren't necessarily that useful, right? Like, and like that doesn't mean that they're worse networks, but like Celestia, it's a DA layer. There's not a lot of like competition to write to the DA layer, right? That's just like it's built for a very different type of use case. Or Filecoin and IPFS, like these are just systems that don't have competition in the same way that like Solana does, And so this is part of why we have this IBRL mode, which we actually just launched today on testnet, which is a mode that actually doesn't have the filtration services in it in the same way. And that's not designed for, I mean, in testing, we're testing it across everything, but that's designed for networks that are both globally distributed, they're high performance, but they don't necessarily have this competitive aspect to it. Right now there's huge amounts of competition for a Solana block. There's not huge amounts of competition for a DA layer or a CDN or a storage protocol. And so, we're starting with the hardest thing first, right? That's very much in our DNA, which is Solana. And so if we can nail the Solana use case, expanding out to other networks and customizing FPGA code to meet whatever they need, or expanding out to these non-competitive use cases that still can benefit from IBRL. If we nail Solana first, the rest is downhill from there.
And I assume competitive use cases here means there's a lot of money to be potentially made if you get into a block. And that's what you guys are going to be like, chains where that is the case, or I guess MEV relays, maybe RPCs.
Yeah. So like, if you don't have competitive markets, you don't have capitalism. You've got something else, right? But like at the end of the day, the reason that trading on a centralized venue is great is competition, right? The reason that companies like Jump and Citadel and DRW have dedicated fiber lines between New York and Chicago and all sorts of other technologies they don't even tell us about, is because there's competition and there's monetary premium and advantage in being first, right? And if you don't have those dynamics on a network, that means just there's not much money being made on a network, right? A network that is not competitive is a network that is largely not profitable. And so that's one of the best things we can look for is competitive trading systems where like I not only have an incentive to try and beat you to the trade, but I have a reward if I beat you to the trade, right? I make more money. Like you look at like high frequency trading, and it's like the fastest person makes 90% of the value, and then the second fastest person makes 5% of the value, and the third fastest person makes 2.5%. It's an extremely sharp declining curve in terms of like value relative to speed. And so that's one of the characteristics of Solana too. And any network that has that same type of characteristic is one that rewards performance, and networks that reward performance are where DoubleZero has highest product market fit. Not to say we're not going to support all other types of use cases as well, but like, you got to chase the North Star first.
Yeah. No, that makes sense. I feel like that speaks to the general shift in crypto that we've had as well, where increasingly it's become more and more competitive. Like we have chains now with 20 validators just because it allows it to run a lot quicker. And similarly, we're seeing more and more HFT and co-location.
Yeah, and so I think this is where it gets in. I think it makes sense to talk about multicast for a minute, because the reason these networks are going to 100 validators or 20 validators, it's not because they're evil and they want to only reward 20 people for running validators. It's that there are like real exponential data problems the more validators you add into a system. And so the faster you try and get, the fewer validators you can get away with, the easier that thing is. And so this is part of like the whole premise of DoubleZero is rejecting that premise and proposing an entirely alternative way to move data around that doesn't require validator sets to get very small to also achieve high performance. And that's multicast. And I think we should have Mateo talk a little bit about that.
Yeah, it's a traffic propagation problem, as simple as that, right? The more validators you add in more places around the world, the harder it is to propagate the traffic out to them. And blockchains, because of the culture of decentralization, they want to be distributed. And so the more distributed they get, the slower they get. It's just a tragic reality of decentralization. And so the way that you fix it, surprise, surprise, is the same way that the stock market fixed it, right? Is using multicast. If you're co-located at NASDAQ, you're going to get a multicast feed with market data on it, because that's the fastest way to propagate data out. Now, what's the problem with multicast? Multicast needs to run on a single ASN. It cannot run on the public internet. And so that's the magic. That's what makes us different from a lot of DePIN projects that have pieces of infrastructure that just get contributed and then used. All of the pieces are part of a whole in this case. They're all making up this single ASN, and that allows us to run multicast over it. And that's very, very efficient compared to the way that normal traffic routes in blockchain. I've been reading some white papers. I love to read new L1 white papers when they come out. They're like, this is the fastest L1. And I'm like, oh, well, how do you propagate traffic? And then I read the traffic propagation piece, and it is this crazy compression thing, trying to fit everything into these tiny box limitations of available bandwidth and throughput. And then they infer statistical conclusions about what might have been propagated. No, just propagate it the way that traders propagate traffic on multicast, with a lot of bandwidth, low latency, and using the multicast groups to get the traffic out to everyone who's subscribed. So we're doing this. We're right now in testing mode on multicast with Jito, and it's going well. It works. We can multicast shreds out very efficiently, and it's revolutionary from a networking perspective in blockchain, because as far as we know, this has never been done before, and it truly is the fastest way to get traffic out.
I'm glad we got two references to the t-shirt, and I'm glad that you guys pointed out that it just makes sense to do what TradFi has been doing. I feel like every year in crypto we figure out, like, sometimes they have come up with good things that we should just copy and make it more decentralized and make it work. I wanted to ask about this DePIN label, because I want to get, do you guys like being referred to as a DePIN network, or is there something else? Because I know you call yourselves N1 as well, and I guess when I think of DoubleZero, I don't think of a DePIN. Is that what you guys are going as?
Yeah, I mean, this is kind of tricky because I think DePIN usually is a system where it is lower quality service but higher reach of service. If you look at Helium, like, it's not as powerful as a cell tower, but you can put it everywhere, right? Hive Mapper, they're not as good cameras as Google Street View, but the frequency of data is so much higher, right? Most DePIN networks have that characteristic. DoubleZero actually has the opposite characteristic. It is much higher quality than the public internet, but it doesn't go everywhere the public internet goes, right? The public internet, I can get it in my house. I can get it in Antarctica. I can get it on the top of a mountain. You can't get DoubleZero in these places. At least maybe Antarctica someday. We'll see about that one. But it's not going to be a residential service that comes into your house. And so I think DePIN is probably the best category name we have at the moment, but it's not a direct fit.
Yeah, and that's why we came up with the N1 idea, because basically it's a base layer of infrastructure, and for us that's sort of the N1 idea: network one, level one, layer one. We have a really cool graph of the OSI model that shows like layers 1 through 7, and shows blockchain up in 4 through 7 and DoubleZero in 1 through 3, right? We're like a low-level infrastructure network, and so it's sort of a new category, but I would say that it's certainly related to physical infrastructure, and it's certainly related to multiple contributors. The difference is the consumption, I think, as well, is that it's like it's a single product that gets consumed as a high quality product, and it's a sum of the individual parts.
That makes sense. Will there be N2s, or will you, in Solana fashion, call it N extensions or something along the lines?
Definitely N2s. There are several ones already in development. And
here's Mateo's OSI chart we were talking about.
Thank you. Yeah, thank you. So you can
Yes.
see the N2s there, and those N2s are all kinds of different applications. There's so many different pieces that are needed to make blockchain performant. There are things like file storage. There are things like coordination of AI training, coordination of inference models. There's stuff like precision time, geo-awareness, all kinds of different things that are needed for the evolution of blockchain. Multiple concurrent leaders requires a lot of this stuff. Multiple concurrent leaders requires some precision time stamps. They require some geo-awareness. So all of these different things need to be built on top of the base layer of infrastructure. And not only are we going to help those people that want to build N2s use the DoubleZero network, but we're going to try to help identify opportunities for those things and bring builders in to build them. So it's exciting. We visualize a whole ecosystem of N2s being built on top of DoubleZero.
Perfect. I have two questions before we wrap it up. The first one is kind of introspective, and I want an honest answer. Is there anything that you guys would have done differently when you guys set off to start DoubleZero? Is there anything that has been a huge bump that you were like, we should have just completely avoided this and instead gone a completely different way?
Nothing really major comes to mind. I think one of the things coming from the Solana world that I underestimated, or maybe overestimated is the right way to put it. I thought there was a lot more activity happening on other chains.
Okay.
Honestly, like I know that sounds very like Solana self-serve, but like our thesis was that every high performance network needs these filtration services, and that was going to be a major benefit to all of these networks out there. Today, there's actually very few networks that have the volume of throughput and inbound where they actually need that filtration, which is part of why the IBRL mode was something we decided to build out more quickly than the original plan for it. Because it's going to take a little while for those. And I think they'll get there, right? This is not like, no one else can compete with Solana. Like everyone's going to be able to compete with Solana at some point. That's the beauty of capitalism. Is when an idea is good enough, a lot of other people start to do it as well. But I think it might take 18 months or something like that for that level of activity to really get to the point where those services are truly required for those other networks as well.
And from the network side, I would say I would have wanted to go directly to 100 gigs backbone instead of 10 gig. We started out with 10 gig. We deployed a lot of Arista boxes all around the world at the 10 gig level. And when we got out into the market talking to people are contributing 100 gig global networks, which is huge. We maybe didn't imagine that people would see it so fast. And so we've now got multiple 100 gig backbones being built all around the world, and those require a different type of hardware that's being deployed. And so we had to go through that upgrade. So if I did it again, I would go directly to 100 gig. I'd be even more bullish on it.
Interesting. Austin, to your point, I think a lot of chains have just decided to instead limit the validator set. And I think we'll see maybe Monad and a few more that are like trying to be both software optimized and larger networks. Last question, what should people expect over the next 6 to 12 months, maybe 18 months? And where can people, where do you want people to go to when they want to learn more about DoubleZero, apart from this podcast?
Yeah, so DoubleZero.xyz has links to become a bandwidth contributor. You can sign up to run a validator, like a Solana validator or an RPC on testnet. 6 months is hard, right? Like in some ways, like 6 months, like I hope we're in mainnet, right? On the 18-month timeline, I think if we are not providing capacity for networks to double and triple and quadruple the available resources on those networks, then I think we've either done something wrong or the ambition of the space is just too small, right? I think the thing that we've seen with Solana and a few other networks that are very hungry is like, and you see this coming back to the Ethereum L1. It's really actually cool to see folks on Ethereum stop parroting this idea that the L1 is not for users and start actually focusing on building something like truly useful for folks. Like that gets me excited that we are about to enter like a high performance blockchain renaissance, and we're going to see people taking performance very seriously. We're going to stop with kind of like the BS blog posts about how many TPS we can do, and we're going to start seeing like a real intense market competition on this stuff. And I think that's going to be awesome. I think also we'll see more specialization, and like DoubleZero like allows for much more specialization because suddenly the network stack is not commoditized. The network stack is like very high performance, and it means that like right now, for example, if you're running a blockchain that does 50 millisecond block times, networking is 90% of your time, right? And it's also very hard to actually make something that's like very fast profitable when you have so much variance around how long it takes data to get into the system and responses back to the system. This is why, like, if you notice, like HFT firms, they don't really invest much in like the physical computer that sits at the exchange. They invest a lot of money in how to get the data to that computer so it can make the right trading decisions. But it's not like they're all building like quantum chips and putting them in data centers. They're mostly focused on how do we break the speed of light, right? How do we move data as quickly as possible into these systems? And so I think if we're able to provide those resources to software developers, people are going to come up with entirely new architectures for blockchain that maybe are even fully hardware accelerated and are just data in, data out, and they're able to use 100 gigabit networks of DoubleZero and Multicast and determined latency and all this stuff to build blockchains that are orders of magnitude faster than people think is possible today. And that's kind of the main thing for me is just like, I think this industry's gotten a little bit complacent with performance and it needs a little bit of a kick in the ass.
Mateo, what about you? What are you looking forward to?
Well, I'm just looking forward to adoption and traffic on the network. So I've got like a visual model that I can share with you about that. If you think about today, the DoubleZero network is a big ring. And all around the edges, you've got internet connectivity. And what's happening today is that you've got these hairpins happening at the edge. Traffic comes in, it finds out that it needs to go to a location on the internet, so it hairpins back out and goes to the internet and then hairpins back in. You can think about it like a flower, like a daisy, with the yellow part in the middle and then all these petals all around the edge, which are the internet hairpinning. And as more validators join the network, those petals start to fall off the daisy and the hairpin stops. And you start to get the native transit, including the multicast distribution of traffic, super efficient in the core of the network. Eventually, you've only got that middle piece, and we've got all of the massive value unlock with the aggregate performance increase that I talked about earlier. So that's really what I'm looking forward to. And if you break it into sort of quarters, by Q3, we expect to have a lot of validators running on the network, a significant amount of stake on the network, and we're going to launch mainnet beta as well, and we'll be sort of in prime time. And then by the end of Q4, we expect to have the real aggregate performance bumps that you see with all of those validators running natively on the network and building blocks natively on the network. So, I'm really looking forward to the end of the year. I'm really looking forward to Breakpoint going, showing the data, the stats that we are talking about, that we're collecting, and having that huge performance bump that we're all working towards.
Very good, guys. thank you so much for coming on. This was fascinating and something that I did not know enough about, and that now I actually think I can say that I understand at a good level. So I really appreciate you coming on and taking the time to explain and talk through.
Wonderful.
Yeah, thank you for having
Pleasure.
us.